morning again. We're going to go ahead and get started. I want to welcome everybody back to our 10th webinar, Loadsense, Low Demand, hosted by Enercon Engineering. It's great to see you guys back, the ones that are returning. And for our new viewers, thank you for joining us. Just a little bit more about Enercon. So Enercon is your power system integration solutions expert. Our products are custom engineered to meet the customer's exact specifications and requirements, however unique. Our main facility is located in East Peoria, Illinois. That is where we do all our designs, manufacturing, and testing. We produce over 40,000 projects, not only domestically, but around the world in 110 different countries. I'm your host, Sean Lott. I am the Director of Business Development. I am actually located in the Enercon Business Development Office in Huntsville, Alabama, which is home to the Redstone Arsenal and the Missile Defense Agency. In 2020, we hosted 6 webinars. This is our 4th webinar this year in 2021. If you missed any of the previous 9 webinars, you can view them at your own leisure on our YouTube page. I'm going to place a link to our page in the chat box, so you can just click it and go to YouTube and see all the webinars there. Or you can just simply go to YouTube and search Enercon Engineering, or you can search for We Are Enercon, and all of our videos will come up on YouTube. And not only webinar videos, but also videos that kind of highlight our going on 46 years of business serving the power industry community. During this presentation, you can feel free to ask questions. There's a Q&A tab. All you do is click it, just type in your question. It's going to be anonymous, so I'll see it. I'll read it, and I will see if Steve can answer your question, and we'll entertain all your questions at the end of the presentation. And today, I'm going to sweeten the pot. So if you are not an Enercon employee, I say again, if you're not an Enercon employee and you ask a question, and it's a good question, I'm going to select a couple of folks to receive our highly coveted Enercon Engineering coin as a gift to you. So be sure to ask questions at the end of the presentation to see if you can get the gift award. Again, highly coveted. Not everybody has one of those coins. So now I want to introduce one of Enercon's treasures, Steve Conrad. Steve is from Springfield, Illinois. He attended DeVry Technology in the late 60s. I say again, he attended DeVry Technology in the late 60s. He worked for companies like Sangamo and Simplex. At Simplex, Steve had his first exposure to power generations and controls, where he manufactured control panels, voltage regulators, diesel fuel day tanks, and switchgear from 1972 to 1977. And then he worked for CAT for 3 years in Kentucky before joining Enercon in 1981, where he served as a testing technician, field technician, supporting over 47 countries, a project design engineer, an engineering manager as well. Steve currently is one of our senior applications engineers. Although Steve retired from Enercon in 2013, he still provides his part-time expertise to the Enercon family, and we're very appreciative of Steve and his vast treasure trove of knowledge that he's providing, not only to us, but also to you as well. So at 40 years with Enercon, Steve is he's our 3rd most tenured employee at Enercon. So ladies and gentlemen, yours truly, Mr. Conrad.
Okay, good morning, everyone. We're going to present Loadsense Low Demand for multiple generator sets with varying loads, and I hope everybody will get something out of this. What is Loadsense Low Demand? Well, it's referred to also as load dependent start-stop. I've heard it referred to as generator optimization, and it's designed basically to match the quantities of generators to the load requirements being served. And it's used with varying loads. If you don't have large varying loads, it's probably not a good fit for the applications. And how does it work? Well, basically, you know, as loads increase, generators are put online, and as loads decrease, generators are taken offline in a pre-selected sequence, and we'll talk more about that. What is used? Well, some of these newer controllers, multifunction controllers, and there's several manufacturers out there. Most all of them do have the control functions to do load sense, load demand. We as a company prefer to use a PLC and a touchscreen. And basically, one of the big advantages is that by using a PLC and a touchscreen, we have one central location where an operator can access and do all his settings. And we'll talk about a lot of these settings and what all is involved. Rather than having to go to each and individual controller and entering a password, it just makes it a lot more operator friendly to allow them to do all this from one central location. And load sense, load demand, we can use that in all these different applications, whether it be standby, prime power, even utility curtailment, where we actually parallel the generators to the utility to try to reduce the loads that we've contracted with the utility. It's probably more common for prime power than standby, although we have done load sense demand applications and projects in all these different types of applications. And it is important to know what your load variance is, and that'll determine how to size your generators and the quantities of generators. Keep in mind that especially diesel generators, not so much gas engines, but diesel engines, you know, they do not like to be lightly loaded. You know, you load a diesel engine probably less than 25% for extended periods of time, and they start developing things like slobber out of the exhaust ports, and it is detrimental to the performance, especially over time. So the big key is to try and keep the generators loaded at least greater than 25%, and then also we need to consider fuel economy, probably more so in a prime power application where fuel cost is going to be very, very much more important. Some of the terminology that we're going to talk about here that we use in describing load sense, load demand. First one is the base unit. We have multiple generators in the system. And the base unit is the first one in sequence. It always stays online regardless of the load. We have to at least have some amount of power available. And then the next units are the standby units. And for example, if we had, let's say, a system where we had 4 generators, we'd have the base unit, and then the second generator in sequence would be the first standby unit. Third generator in sequence would be the second standby unit, and so on. I think we have done, I think we did a load sense, load demand system once with 6 units. And then walk on is a process of putting a generator online, which involves, of course, starting, synchronizing, closing the breaker, and then applying load. Walk off is the process of taking a generator set offline, and we don't just open the breaker. We actually cause it to softly unload in a controlled rate. We open the breaker, then run the engine and cool down, and then stop it automatically, waiting for load to increase to put the unit back online. And then out of service. Out of service basically means the generator set is not available for fully automatic operation. And if a generator is out of service, then it will be skipped in the sequence. And out of service, basically, there's several things that will allow a unit to be in service. It has to be an automatic. It has to have any relay tripping or anything like that. It has to be reset. So there's a whole myriad of conditions that have to be met to determine that a unit is actually in service and not out of service, if you will. And some of the other terminology that we're going to talk about is the sequence. And this is the order that the generator sets are placed online or taken offline in this sequence. This is an operator assigned sequence. Spinning reserve. What spinning reserve, what we refer to this is the kW that's left over after you apply load to the generator set. And here in this example, we have two 500 kW generator sets. And if we have a total load of 800 kW, then there's 200 kW that's left and it's spinning, it's ready to go. We don't have to wait for engine starting or things like that. And this is how essentially we monitor this spinning reserve. And this is makes the determination of when we put units online or when we take units offline. Percent of output. Some companies use this rather than the spinning reserve method. Basically, they look to see how much load is on the generator set individually. There's not a whole lot of difference between the two methods. I've always chosen to use the spinning reserve method. And let me talk a little bit about the generator sequences. This little chart here, basically, if you've only got two generators, then you've only got two sequences, 1, 2, or 2, 1. And the number of sequences increases exponentially, as you can see. For example, if we jump up to 3 generators, then there's 6 sequences. We've got 1, 2, 3, 1, 3, 2. We've got 2, 1, 3, 2, 3, 1. And then there's 3, 1, 2, or 3, 2, 1. So 6 possible sequences with 3 generators. Some of the higher numbers may tend to overwhelm operators, but what we basically say is, if you look at engine running hours, probably always keep the engines with the highest number of operating hours at the end of the sequence. And periodically adjust those, because at times your engines are going to require oil changes and things like that. So even though some of these number of sequences seem very large, don't get too overwhelmed by them, like I said. All right, let's look at the set points. What happened? Stand by, folks.
Yeah, hold on just a second. I'm not sure why it dropped like that, but we'll get you back up here in a second. There you go, Steve, you back up?
Yep.
Okay. And there you go.
All right, now we're going to talk about the set points. I need control, Nick. And basically the set points, we have 2 set points for adding generator sets. And again, this is all looking at the spinning reserve. And if the spinning reserve has just slightly gone below the set point, we have a timer, and each one of these set points has a timer associated with it. So if it's just slightly over, we're not in a crisis situation where we need to get one on immediately. So we can wait a little longer. Then there's a fast add set point. So if that spinning reserve drops way down, then we may want to get a generator on a little bit shorter time. So we go into the fast add set point. And then we have the walk off set point. And basically, as the loads decrease and that spinning reserve increases, when it goes above the set point, then we have determined that we can actually take a generator offline. And then, as I said, associated with the set point, there are some time delays. The first time delay is what we call the transitional timer. And basically, after a system is started, and here I'll probably use an example of for standby. We've lost utility, so we start the system. All the generators initially go online, loads applied, we can wait. And then after this transitional timer times out, then the load sensing is looked at, the spinning reserves, and we start the operation. And the slow add timer, again, it's just the timer that's associated with the slow add set point. Same with the fast add timer. And then we have a walk off timer. And basically these timers are used to get past surges. A lot of times you may just have a load surge, but it's not to a point where you need to get a generator online or offline. And that's the whole purpose and intent of using these timers. Let's go through a operational sequence of we actually start Loadsense load demand. The first thing that happens is we receive a start signal. All the generators are started. The first generator, of course, that's going to attain voltage and frequency, it's got to close to a dead bus. And as it closes to a dead bus, it has to initially supply any loads that are connected. If it's a standby application, load may not be applied until transfer switches transfer, things like that. And then, of course, the remaining generators, they're just going to randomly synchronize. They're going to close their breakers when they're in sync. And then we start the transition timer. And then the remaining loads are applied to the online generators. And it gives time for everything to settle down before we start looking to see whether we need to keep them online or start taking them off. And of course, they're all operating in load sharing. So the loads, as the loads increase and decrease, they are shared amongst the generators. And then when the transitional timer expires, then the spinning reserve set points are looked at, and then we make the determination whether we need to keep them online or take them offline. Nick, we lost this again. There we go. All right, I apologize. We have some technical glitches here. All right, let's go now into the walk-off sequence. So the controls have determined, due to the spinning reserve being above the set point, we don't need all these generators. So we start the walk-off timer. Now, during this timer, as it's timing, if all of a sudden the spinning reserve were to fall below, then the timer would be reset and we would wait again. So let's say that the walk-off timer finally does expire, and we're going to walk off the last generator in sequence. And again, we don't just open the breaker. we take that last generator in the sequence, we soft unload it to near zero. And as we are unloading it, that load gets shifted to the other generators online, and they go into a load share level. And then when that last generator in sequence, it's unloaded, the breaker opens, the engines run for a cool down period, and then automatically shut down. And then that walk-off timer is reset. Now, let's say, for example, that we have 4 generators, but the load only requires 2. We're not going to just walk 2 of them off simultaneously. We're going to walk off one, then we'll reset the timer, and then we'll walk off another one if we don't need it. And again, if we do need to walk off, we will go back to step 2, where we start that timer timing again, and then we go back through that whole sequence before we would take another unit offline. Here's the walk-on sequence. Controls have determined that another generator is required because we've dropped below the spinning reserve set point. Depending on how far, we would determine, are we going to look at the slow add or the fast add and start the timer timing. Okay, here we go. I keep apologizing. We'll have to look to figure out what's going on with this. So anyway, we've determined that we don't need all the generators. So the add timer starts timing. Either the slow add or the fast add timer expires. And the next generator in sequence is started. It's synchronized, breaker closes. And again, remember, if the next one in sequence is out of service, for example, then we would skip over that one and it'll start the next one in sequence that is available. And again, once it goes online, goes into the load share levels. So all the generators are essentially supplying the same percentage of load. The add timer is reset. And then if the spinning reserve is still below the set point, then we just go back in sequence to number 2 and start the timer's timing and so forth. There we go. Now, this is a spreadsheet that I did. I don't want to spend a whole lot of time on this. This is available. It can be downloaded. And basically what this shows is we've got 5 generators. They're all rated for 1,000 kilowatts. We've got an add set point of 200 kW. So spinning reserve goes down to 199 kW. Then we're going to start the next unit in sequence. And if you notice, I stepped through with 1 gen set online and then 2 and then 3. So you can look through this and you can see the load levels of each generator set. And then on the far right of this spreadsheet, I display what the spinning reserve KW is expressed in KW and then also expressed in percent. And then I'll also show what the actual total load KW just gives you an idea of how they load share, what percentage of load they are at. And again, this is available you can download this on the website. It's not advancing. All right, now we're going to look at some other control functions. We have had some customers, very critical type loads, maybe at a data center, where they want a minimum number online. For example, they don't care what the load is. They always want at least 2 units to stay online, just in case if one of them were to trip out, they wouldn't lose power. So that is one control function that can be utilized. Pre-alarm replacement. This is a very nice feature to have. And basically what this does is, let's just say, for an example, that we have 4 generator sets, and let's say that the load only requires 2 of them. And let's say that the second generator, which is the first standby, it has a pre-alarm, maybe a high water temperature alarm, maybe the radiator's clogged through a belt, who knows. But we detect that it has developed a pre-alarm. If we don't do anything, it could eventually lead to a shutdown, which could then overload the generator sets that are online. So what we do, we detect the pre-alarm, and then we go ahead and start the next one in sequence, let it synchronize, let it load up to the load share level. Then we take this unit that has developed the pre-alarm and we unload it to down near 0, trip the breaker, and run it in cool down, if it will run in cool down. And then, so we haven't lost anything. Operators can then go to that unit and rectify the problem there, and then put it back in service, or they can change the sequence, whatever they want to do. We always start all units if we detect a bus under frequency. So let's say, for example, we've got 4 generators and only 2 is required. One of them shuts down on a fault or whatever. That one that's left online, if it goes under frequency, then what we do is typically would initiate some load shedding, automatic load shedding. But we would also signal all the units to start, and then we would go back and reset that transition timer, just like the system is started up initially. And the goal is, of course, to try at least to maintain enough adequate power online to satisfy the load requirements. Anticipated load, we have done this before, probably more common for prime power applications. Somebody knows exactly some certain time, some load's going to come on that they know is going to require another generator. So they can either send us a request signal, or there's several ways to do this, but basically what it'll do is, just even though the load sensing doesn't require it, it'll go ahead and start another generator, put it online, and then usually there's a timer associated. If the anticipated load never does come on, then we'll go back and do our normal load sensing and take a unit back offline if it's not needed. Unequal KW set ratings. This is a challenge. We have done load sensing with unequal KW, but the thing about unequal KW, the settings are also dependent on the sequence. It's not very common, but some applications, specifically probably prime power applications, like at a mine site, for example, they may have a very light load, say at night. So they may have a very small generator set, and then during the day when the mine's in operation, they'd have much larger sets running. So to put this in fully automatic for the sensing, the sequence is not just based on the spinning reserve settings. It also has to look at the sequence, because you may walk off a large one, leave a small one, or vice versa. So that does require a lot more calculations within the PLC. Okay, that concludes the presentation. Are there any questions?
Thanks so much, Steve. Appreciate the presentation and flexibility. Thanks to the audience for staying with us. We do have a few questions, but before I get started into the questions, I want to make sure that to remind folks, if you do have a question, just click the Q&A tab and we will get your questions answered as soon as possible. So the first question for you, Steve, is can the sequence be changed during operation, or does an operator have to wait till the system is not running?
No, actually, an operator can go in there and change the settings. Even though it's in operation, you know, there are checks in the program, in the PLC program. You know, for example, if he doesn't enter the sequence properly, you know, if he's got a missing unit, a missing number, the program, it's got checks and balances in it. But yes, an operator can change the settings while it's in operation without any causing any detrimental problems at all. Yep.
Okay. All right. The next question we have is, can you program this PLC to alternate which unit is the base unit?
Yes. Yeah, we typically don't do it, but yes, you could automatically, for example, you could automatically adjust the sequence based on running hours. But one of the issues that we see is, you know, we like operators to at least be aware, you know, and it's a case of out of sight, out of mind, you know, you tend to forget about things. But yes, that could be done. I would venture to guess that we probably have done that before. It's just typically not our standard though, but yeah, that is a very good question.
Interesting. So what if you have an operator enter the incorrect set points, or they go out of sequence?
I'm sorry, Sean.
Yeah, what if an operator enters incorrect set points?
Okay, again, we have in the PLC program, we have some checks, you know, for example, slow add and fast add. Is it possible to get those, either the settings or the time delays screwed up? No, because again, we've got checks and things in the program to prevent that, you know, quite simple. For example, we would not allow the slow add time to be set shorter than the fast add time, and same with the set points. So again, there are things in that program to keep an operator honest and keep him out of trouble. Yeah.
Okay, I see. And this question kind of dovetails off of that response. But what happens if the next generator in walk on sequence fails to start or sync?
Well, if you have in the sequence, you know, if it is going to tell the next generator to start, and if it had you know, a failed to sequence, a fail to synchronize, or any type of an abnormality, then basically what we would do would be just to skip that unit and go on to the next one.
And how fast, when you say skip the next unit, how fast does that occur?
Well, of course, a lot of that is going to depend on the size of the generator set, you know, because, you know, typically, if we tell a generator to start, you know, we're going to know if it fails to synchronize, for example, or we're going to, if it doesn't start, we're going to know that it overcranks. So just as soon as we sense an abnormality, that's when we would skip and go to the next unit in sequence. And, you know, typically, for example, let's just look at a 1000 kW genset. You know, typically from the time you signal it to start, if everything's working fine, to the time that the breaker closes, you know, sometimes can be as short as 5, 6, 7 seconds, and you got another unit online.
Okay, yeah, that's pretty fast. So do all these generators have to be of similar kilowatts?
No, and we have done Loadsense low demand systems with unequal kW, but again, that also depends not only just on the set points, but it also and the calculations are a lot more complicated because again, we have to look at the sequence, not only just the set points.
Okay. The next question is, how could this application be used for utility curtailment?
Say that again, Sean. I'm having trouble hearing you.
Yeah, how could this application be used for utility curtailment?
Okay. Yeah, if you have an application where your generator sets were set up for curtailment, in other words, you're going to parallel with the utility. Utility is going to call you up and say, hey, you need to reduce your load to 1 megawatt or 500, and again, if you're at an application where your loads can greatly vary, it may be times where maybe a single generator set can satisfy the curtailment requirements, or there may be times when it may take 2 or 3 units that you have, depending on what your load is. So that's why I say that Loadsense low demand applications can also work with paralleling with utility for curtailment. Yes.
Okay, and are these load sharing settings automatically adjusted when one of the gensets suddenly shuts down? So is that an automatic process that happens?
Yeah, if you lose a generator set, the load sharing is that's going to be automatic, and that's part of the setup of the controller. Whether it's a Woodward controller, a ComApp controller, or whomever, but you do have some settings that you have to do, initially to get all the settings done properly, and then yeah, the load sharing will pretty much take care of it automatically.
And does it divide the load across all the available gensets that are running, that are online?
Oh yes, all of them that are online, they will load share. Yes. Now, when I say load share, they load share proportionally. So if they're all the same kW genset, then load sharing will be equal. If they're not the same kW gensets, then the load sharing would be done proportionally. For example, if you had a 500 kW set and a 1000 kW set, then the load sharing would always be 2 to 1. In other words, the smaller set would always take a third, the larger set would always take 2/3 if they were 500 and 1000. So unequal kW, they load share proportionally. Equal kW generator sets, they load share equally.
Okay. And our next question has to do with pre-alarm replacement. So with pre-alarm replacement, is that generator auto taken out of service, or do you have to manually do it?
No. What happens with the pre-alarm replacement, as soon as we detect an alarm and we put the next generator on in sequence, then we would soft unload the unit that had the pre-alarm. And once it shut down, no, we would consider that out of service. It's, now if the operator went and, as earlier I'd mentioned, maybe a clogged radiator or something like that. If an operator went and fixed the problem, and then all he would have to do would be to put that unit back in automatic. Now, if he didn't change the sequence, if all he did was fix the problem, put that unit back in automatic, then what would happen is, yeah, that unit would go back, it would start, it would synchronize, and then the last one that replaced it, then it would shut down. And that's why I was saying earlier that, all these settings and everything can be done while this thing is in operation without any, causing any issues or abnormalities in the system, if you will.
Okay. And our next question, let's see, is this type of load control preferred or something like droop or base load slash swing bus?
Well, basically, especially with this day and age, with the technologies, we rarely are you going to run these things in droop. Um, just because of the technologies that's out there with the controllers, especially new engines, they're all electronically controlled. The fuel injection, it's all electronically controlled. So they're pretty much all going to operate in load share for the kilowatts, and the same with the regulators. Just due to the technology that's out there, the regulators are going to run in bar share mode, and the governors, well, I say governors, let's just say the engine control is basically always just going to operate in load share. However, as we load and unload units, of course, if we're going to take a unit offline, we're going to take it out of load share so that we can unload it. And conversely, if we're going to add a unit, we're going to let it go up to the load share level. But as long as they're online, operating with the other units, no, they'll be in load share mode.
Okay. And next question here is, did you program the alarm unit to automatically move to the last unit of the sequence so you don't experience it coming back online when the operator repairs the fault or alarm him? Or alarm.
Now, wait a minute, say that again. I'm having some trouble hearing you there.
Yeah, can you program the alarm unit to automatically move to the last unit of the sequence so you don't experience it coming back online when the operator repairs the fault or alarm?
Well, yeah, generally what we do is we just go to the next unit. If we develop a pre-alarm, we don't go to the last unit in sequence. We just jump to the next one. And of course, if that unit wasn't available, out of service or whatever, of course, then it would just keep on skipping down and until it found a unit that was available, pretty much.
Okay. And yeah, I'm trying to remember, we're getting a lot of questions, so I'm trying to remember if we answered this one or not. I'm not sure if we did, Steve. But what generator controls are being used?
Well, we primarily, as a standard, we pretty much use Woodward EasyGen controllers, although we have used other manufacturers' controllers. I mean, there's DIFAs out there, there's ComApp, there's a whole bunch of different manufacturers. It's just that we've just kind of standardized on the Woodward controllers, the EasyGen.
So is there an optimal solution based on a requirement? So that requires further kind of investigation on our part in order to come up with the best controller solution to satisfy customer needs?
No, like I said, we and all these controllers are pretty much feature wise. Almost all of them pretty much have the same features, and it's just preference, I guess.
Okay. Is it possible to load share on different brands of gensets connected on common bus with different controller like ComApp and Woodward?
That's a very good question. Typically, I would say no, but there are ways around some of this stuff. And that's one of the nice things about a PLC. And there are other devices out there. For example, here's a good example. Woodward. If you have, let's say, an older system that had just an analog type governor, like a 2301, let's say load share governor, and that's existing. And customer purchase and installs a new generator, and it's going to be electronic. There's not going to be any load share governor or anything like that. Most of these controllers communicate to each other over what's called a CAN bus network. And like, for example, Woodward, they do have a device that'll convert CAN bus to analog load share. So yeah, we can take new units and parallel them with older units. As far as different manufacturers, I would say that with the PLC, I'm sure there's always a way to do it. Yeah.
Okay. And our next question is, do you adjust unit sequencing for things like hours spread and maintenance intervals?
Typically standard, we don't do that. We have done that before. And again, it's this thing, out of sight, out of mind. We don't want an operator to just totally forget about it. Typically an operator would log things like running hours, and we kind of think it's better to have an operator to enter the sequence manually and possibly base it on running hours. If you had a system where you had 4 or 5 generator sets, you certainly wouldn't want all your generator sets to require maintenance exactly at the same time, which we always feel is another reason why an operator has to be aware of all, of things like running hours and things like that, if you will.
Okay. All right. The next question is, for a setup of more than 10 generator sets, more than 10 gen sets with 2,000 kilowatts, for example, how do you test the LS-LD function? Is there a way for a simulation, for that to be simulated to do a test?
Well, I think if you want to talk about simulation, I think that would probably require some sort of maybe a dedicated PLC just to do, something like that. I think, if I'm thinking right, I think we did a Loadsense low demand system with 6 generator sets. I don't know if we've done any with 10. It's certainly possible. It's pretty much unlimited. Most of the governor manufacturers and things like that, there are a limitation as to how many units they can have load share, but that's probably well within the limitations of what we do with these type of systems. But yeah, as far as simulation, I would think that simulation, I don't think you'd want to use the same PLC that you're going to do the Loadsense low demand control. I don't think you'd want to use the same PLC to simulate. I think that would be better just to have a little standalone simulator, something that an operator could play around with to his heart's content and stay out of trouble.
Okay, I'm scanning the Q&A. As I'm doing that, though, we had some requests for this actual briefing. So what I did is I posted 3 PDF files into the chat box for you to download at your own leisure. So one is the book.
Yeah. One thing that I did want to mention too, there is one other document that's for the download, and it basically goes through, it's quite a few pages, but it goes through all the calculations and shows you how to derive the set points and the time delays, and it's very involved. But that document is available for download. It was a Word doc, but you said, Sean, that you changed that to PDF, right?
Yeah, I made a PDF just to compress the data a little bit. But the basically 3 documents or PDFs that got uploaded into the chat box, so you can download them if you so choose. One is the Loadsense Loadsense demand settings overview. That's one. The other one is the load sensing spinning reserve calculations that Steve is presented as well. And then the other one is just a copy of the presentation that Steve put together. So all three of those are in the chat box for you.
Oh, very good.
All right, Steve. Well, thank you so much for a very informative discussion. And
thank you. I enjoyed it.
Yeah, you up for one more question? We have like 9 minutes on the clock. Let's I'm gonna ask it. Let's see here. Have you designed a solution to get the EasyGen or other controller based on CAN to get data from CDL, i.e. an old CAT XQ2000 with Atom 2 and SPM Alpha and LSM?
Well, with the XQ, that's probably I don't know necessarily what vintage it is. I don't know what version of the EMCP, the engine control module. I don't know what version that is, but generally what we can do, and of course the ADEM governor, there's certainly no issues interfacing the ADEM with just about anybody controller. I think most of the ADEM use pulse width modulation, and most all the controllers will do that. Depending on what the EMCP version is, typically we can communicate with that, either Modbus or the newer ones. Some of the higher end ones have Ethernet, so we can communicate with those devices and incorporate a lot of this data, this information, incorporate this into our Loadsense load demand systems.
All right, well, I appreciate that. So that wraps up Q&A. So thanks again, Steve, for your wealth of knowledge. Just
good,
a reminder.
Very good questions too. Very good questions.
Yes, I agree. Somebody mentioned they had problems downloading the documents, so I went ahead and reposted them. So if there's still an issue, please let me know via chat, and I will not repost them if there's still an issue. What I'll do is I'll send it out to your email accounts that you use to register for the webinar right after this. Also, as a reminder, sure, no problem, you're welcome. Okay, I'm here. I'm seeing that they're not coming through, so I'll send it out on email. I got you guys. So also, just to let you, as a reminder, you see all our social media handles and things, YouTube, Twitter, LinkedIn, Facebook. We're all over the place. So to be informed on things that Enercon is getting involved with and what Enercon is doing with webinars and outside of webinars, with our projects and our business adventures, just go to one of those pages, like the page or subscribe to the page, however that page is done, and then you'll get notified instantaneously as soon as we post. This presentation that Steve gave, the actual video presentation, will be posted on Facebook and on YouTube this afternoon. So once that is done, and if you are subscribed, you get notified of that as well. And it's everything is shareable. So anytime you get an invite from us for a webinar, you can forward that to your counterparts at work or whomever you want to share it with, and they can register with the same invite that you received. And we very much appreciate that. And you can also share any of our video contents that you see on YouTube or on Facebook. So with that, our next webinar is on June 22nd, and it is on maintaining power systems, which is going to be presented by Mr. Scott Wolf, and it's going to be at the same time, Central Daylight Time. Did I say May? I meant to say June 22nd. June 22nd. This year is just kind of speeding on by here. So June 22nd, and we look forward to seeing you there, and you'll also get an invite to that webinar in your inbox as well. So on behalf of the Enercon Engineering family, we want to thank you guys for attending. And whatever you're doing for this Memorial Day, please take a few moments to remember our men and women who have served our armed forces and paid the ultimate sacrifice for us to do the things that we enjoy doing here in this great country. So we appreciate that. So thank you for joining, and we will see you next time.